ISRO's Aditya L1 has been launched successfully on Saturday, will not land on the Sun, but be positioned at the L1 point in the Earth-Sun system.
5, 4, 3, 2, 1, 0. Plus 5 seconds.
Liftoff normal.
P1 tracking.
P3 tracking.
Magnificent liftoff of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के
Plus
तेज से
25
विज्ञान को प्रकाश करने।
Airlift trap on ignited.
इसके
Aditya L1 land on the Sun? No. Unlike Chandrayaan 3, where the Vikram lander, with Pragyan rover inside, softly touched down near the lunar south pole, the solar probe will instead be positioned at the first Lagrange point in the Earth-Sun system. The distance to the L1 point is 1.5 million km, a span anticipated to be traversed by the spacecraft through various maneuvers over the course of 4 months, ISRO said.
Aditya L1 has a long list of objectives. The ISRO wants to know more about the Sun's outer layer. It is called the corona. Not the kind of corona that China became famous for. This is about the Sun. ISRO wants to understand how the Sun works. And by that I mean solar activity. How it affects the planets in our solar system. Things like solar flares and solar winds. How do they affect the Earth? ISRO will try to answer all these questions with this mission. It plans to travel to a very special location near the Sun. It is called the Lagrange point 1 or L1, the one that we mentioned earlier. And what is special about L1? Let me use the example of a seesaw to understand how this works. How does a seesaw work? It always tilts on the heavier side. And when that happens, the lighter side goes up and the person on the heavier side goes down. The Earth and the Sun work in a similar way, like two sides of a seesaw. They're constantly shifting. The Sun is very large, so it exerts a lot of force, a great force on the Earth, gravitational force. And the Earth is constantly moving around the Sun, so it cancels out the Sun's gravitational force. The craft would remain in position. It will not feel the impact of gravity, plus it will save fuel. And the views are great. There won't be any obstruction. The US Space Agency, NASA, agrees. It says at L1 you'll get an uninterrupted view of the Sun. So we're hoping for some good pictures, but getting there is no cakewalk. The L1 spot is 1.5 million kilometers away from the Earth. Now we try to do some math here. If you were to drive your car to L1 at 100 kilometers per hour, you'd take almost 2 years to get there. And I'll be honest, our maths is not as good as ISRO scientists, but even we know that you can't drive cars in space. So this was just to give you an idea of how far it is. Of course, ISRO has figured out a more efficient way of getting there. They say it will take 4 months for the spacecraft to reach. And this is a very important mission. You see, the Sun is the nearest star to the Earth, and it behaves a bit like Thanos. With its 5 infinity stones, it releases immense amounts of energy. Scientists have a term for it. Eruptive phenomena, that's what they call it. Simply put, it means large bursts of energy, sort of like the Sun catching a cold and sneezing. Now, we don't know what happens after that. And by we, I mean humankind. We don't know. We have a very limited understanding of how the Sun works. We need to study it better and also to prepare for situations that may potentially harm our planet. Aditya L1 aims to deliver this to help us understand what's going on up there. And in typical ISRO style, this is a mission on a budget. The government of India cleared it in 2019. $46 million were set aside for this mission. That's less than Chandrayaan. Chandrayaan 3's budget. The moon mission cost $75 million. And it proved to be a good investment.
Remarkably, this distance represents only 1% of the overall 150 million kilometer separation between Earth and the Sun. NASA's Parker probe touched Sun.
Here's a fascinating viral video from the Sun. Yes, we did it. NASA's probe literally touched the Sun. This is just amazing. It's like it's been cut right out of a sci-fi movie. What we see in this video is Parker spacecraft's view as it passes into the Sun's upper atmosphere, the corona. The Sun's corona is the outermost part of its atmosphere. usually hidden by the bright light of its surface, but can be seen during a total solar eclipse. This video is made out of individual images gathered between August 8 and 12 of 2021, while the probe was closest to the Sun. What makes it even more breathtaking is the appearance of the Milky Way galaxy in the background. The video is captured by Parker Probe's Wide Field Imager for Solar Probe. The streaks probe is zooming through are coronal or helmet streamers, electrically charged gas and plasma that are made over active regions of the Sun. Closed magnetic loops that connect regions of opposite magnetic polarity on the Sun. Electrons got captured in these loops and caused them to glow very brightly. Again, this is what we see around the Sun during an eclipse. You can see streamers here as the probe flies above and below them inside the corona. Parker here is moving at speeds up to 91 miles or 147 kilometers per second. 328,830 miles or 529,200 kilometers per hour. We're not done with this video yet. Believe it or not, there are also planets visible in the background, including Earth. The NASA itself hasn't exactly identified the planets, but there are assumptions online made by astrophysicists. First, we see Venus, Mercury, and Mars. Then we see our Milky Way galaxy, and then Jupiter, Earth, and Saturn. This is just the beginning for the Parker probe. Every time the Parker passes close to the Sun, it's going to fly through the solar corona. The spacecraft has still another 15 spots around the Sun to travel to before completing its mission. This is a giant leap for solar science. Just like landing on the Moon allowed scientists to understand how it was formed, this historic closest encounter to the Sun would allow us to gather data that helps us to address some of the biggest questions about the Sun and its dominance on the solar system.